Last time I started a new stage of my compiler for the Elna programming language. The compiler is written in itself and it is written in stages, so the early stages have only few features of the language itself, but each stage adds new features that can be used by the next stage. And now we are on the stage 17, and I still have to do some cleanup in this stage to apply the features that were implemented in the previous stage 16. And for that I will look for some auto-generated functions that can be now removed. And we begin by assign statement get from parser tree. So the prefix of this get function is assign statement, and it says us that parser tree is of type assign statement, or it is a pointer to an assign statement. And then we set the type. We can replace this function with the postfix, the part that goes after the get. So we can just write it this way, dereferencing, and then field access, and this can be removed. It should compile. Then we can check where the current expression is used. So this one can be just replaced. This usage can be replaced with the expression. Then we can remove this one. And later we see actually the same pattern, but this is another field of the expression of the assignment statement. So it gets the assignment field, just like let us see where the current expression is used, and this is the only place. So basically we can write here parser tree, dereferencing, on field access. We need the assignment field. Then we can remove this assignment. And the variable itself isn't used, so we can remove it as well. And check other places where such getters can be used. I already replaced all setters with the field access, so it is already done. Get statements. So here we see that the parser node is a pointer to a conditional statements type, so we replace this generic word type with conditional statements, and this basically it is the same. So instead of current node we can just write parser node condition, I suppose, and current node is probably used later and passed here. So this one is just parser node statements, and we shouldn't forget to dereference the pointer to access the field. and this assignment can be then removed, and this assignment can be removed, and the variable itself probably too, it was current node, so it isn't used anymore in this procedure, and it can go. So let us check for other places where we can have similar. So yes, this Elna type assign statement. It sets probably the types on the left and right sides of the assignment statement. So we get the type and set the correct type for the parser node. And this LHS and RHS variables, we don't need them anymore. So here we can just write parser node assignee, and here parser node assignment. These two can go and the variables can go. Then we look for Elna3 node get kind. Yes, there are some usages of that function, and actually parser node is then it is actually a statement, but I don't think that I have an extra type for the statements. So we just assume here that it is a generic tree node type. So any abstract syntax tree node, and then we can actually check this field directly in the if expressions. So this is then parser node kind, parser node kind, parser node kind, and parser node kind. That should function. We can remove the assignment, and we can remove the variable. I tested once again, and I think that it wasn't the only place where it was used. So we check again, and here kind is called on the result, and result is also untyped, so to say. This one should be actually nil. So nil wasn't supported some time ago, and therefore a lot of places use 0 instead of nil. It is how our language improves with each stage. So the result should be actually Elna 3 node, I suppose. Here we just call our actual procedures, but here we get the type, the kind of the result node. So we can do it this way. And we just check whether it is a call expression. So we actually don't need this temporary variable. we can just put it in here now, and temporarily can be removed as well. That kind. There's still quite a few usages of this procedure, or this getKind function. So here it is, the parser node again, and we do the same. We say that parser node is some elna3 node, and then we replace this statement kind with the direct field access parser node kind. The same here. And otherwise it's nil. We look for the next occurrence. So this is in a name type expression. So basically parser node is some type expression. And this one is a bit more difficult. So we begin with just generic elna3 node. And we replace this token kind with parser node kind. And see if it gets compiled. It does, so we don't need a token kind variable anymore and this procedure, but we need an additional variable and we call it named type expression. A named type expression is just a type name. So for example, word here is a named type expression. This one is a pointer type expression because it has a pointer sign, a head, and a type name. We can remove this assignment. And what we do, we assign this named type expression, we assign the parser node to it. The reason for that is that here we check that the type expression that we handle is a named type expression, and to cast a parser node to a named type expression, we assign it to a variable of this type, and we should of course then give the correct type to this variable. So it's basically a cast because we don't support cast statements in this current stage, but we will add them later, but they are not that important for now. This means that we can now query the fields of this name type expression, and for example this type name is probably used only in a single procedure call, so we can just directly replace it with named type expression name, and the name length can be replaced then with named type expression length. And then these two can be removed. And here we use the result variable for two different things. So let us remove one variable and rename the other one into type symbol, and its type will be a pointer to a type info object. And then we assign the lookup in the symbol table to this variable type symbol, and then we can access the type stored in this type info object. So we basically say type symbol I hope it was type. Well, it is fine now. I think that Elna3 node getKind is done. Then this one is probably also done. Conditionals. Now we have still one occurrence here. So parser node is an if statement, because it is a procedure that converts an if statement into the intermediate representation. So we write if statement here with an underscore, and then this current node is used here and here, so we can just replace this current node directly with parser node conditionals, and this assignment can be removed then. Or maybe not. Parser node conditionals, current node, here it is reassigned. Oh, but we get the next from the current node. So current node here is exactly the same. Parser node conditionals again. And it hangs. Yeah, because we use always the same thing. So this assignment before, it was actually important, because this list of conditionals is a list of else if blocks, and it is a list, and current node keeps the current else if block. So this assignment was important. We assigned the if block to it at the original run. So it is parser node conditionals. We can use parser node conditionals or current node here, it doesn't matter. Let us write current node again. The important part was to get rid of this getter, and we have done that. And here we pass the current element of the list. It gets the next element of the list and assigns it to this current node again. So we can just rewrite it to current node next. It should actually do the job. Current node is current node next. Exactly, because current node doesn't actually have a type assigned to it. It would be nice if I would know what the type is. I think it's let us look into the type definitions. So I had somewhere conditional statements record, and this is probably the type of this thing. Conditional statements. Let us try once more time. And now it looks much better. So this was the last statement that we changed. We have also here this get else access, so it accessed the else field from the parser node and assigns it to the current node. This is actually nil, and this is exactly the same. We can say current node, but I think current node is conditional statements, and conditional statements is a pair of a condition and a block, but else is not a conditional statements. Else is just a block because we don't have a condition in else, so we just replace this current node because it has actually a wrong type, and we just use parser node else directly. Current node then we create an instruction, check if it is nil. This isn't interesting to us, so let us check if it still compiles. And as it does, we go looking for the next procedure statement. Get conditionals, conditional statements get. Then we have if statement get. Then we have elna3 node get kind. We had it already. Then we have elna3 named type expression get. Type info get. Okay, this one is used 5 times, even 5 times. So symbol info. Symbol info in this example should be a type info. So we just say that this is a type info pointer, and then we have just assign the type tweet. Type info get type symbol info. I think it is actually correct. So the property, the field was named typed. Yeah, I just forgot to dereference it. And here here we have exactly the same situation. So we say that symbol info is type info pointer, and then we dereference this pointer and get the type from it. Once again with the same, and I will just copy the line. So what do we have here? Almost the same. Is this symbol type used at all? No. So the same. We just copy it, and here it looks actually the same. And this is the last usage, and we have to here actually here here we can see a lot of getters that are still used, so we can just begin with the beginning of this procedure, and we have field access expression as the first argument, so its type is this prefix. We replace the generic word type with the field access expression type, and then we can just access its fields. So now we need to set the type of this symbol, and I actually think that this is this is a variable expression. Symbol, it's here, and we can then say name, and then we can say length. This value name and value length variables are used here, and we replace them here just with these calls, symbol name and symbol length, and then we can remove the assignments. So then we expect that this symbol has a different type because we reassign it. I should have defined a new variable. Enumeration type. enumeration type is then used as well. We can replace enumeration type first, so the enumeration type should have the type ELNA type enumeration. So we change the type of this variable, and it gives us the access to the fields of this type. So the first one is members, and the second one is the number of enumeration values in the list, so it's just called length. I hope that I don't reassign this enumeration type with something else. I don't. So basically I can replace these members variables just with a field access. So we can say here length and we can't, I suppose, because I implement here a loop and I check each enumeration value that we have seen in the filter access expression. I check it in the enumeration type, and each enumeration value is saved in this members variable. So this should be actually really member length. Okay. I think it isn't what it was originally. Oh, so I have two variables, member length and members length, I suppose. And only member length is changed, by members length is actually constant. Because actually no, it shouldn't. Where do I change this member length variable? Here I subtract 1, and so I go through all of the members of the enumeration. So we have to let it be members length, otherwise it enters an indefinite loop. We already know that field access expression is ELNA 3 field access expression. That's correct. So we can access these value name fields, and they are used in this string comparison function, and I have a strong feeling that I can just replace them with the field and the length of the field name, not name but length. So let us see. Yes, this looks fine, and this value name variables aren't used anymore probably. Value name and name length isn't used either, so we can get rid of them. we will remove the one and we will rename and use the other one. So we need a variable for the symbol info, and we will call it symbol info, and we will say that this symbol info is a pointer to the type info object. And now, instead of reusing this symbol here, actually it is kind of wrong. Symbol length, symbol name. What is the type of symbol? ELNA3 variable expression. Let us remove this one. So we get the left side of filter access expression for an enumeration. It is basically a type name. Let us call it this enumeration type name. And here we use this enumeration type name variable, and we use it here, enumeration type name and enumeration type name. But we don't have a symbol anymore, of course. So now we need a symbol variable. Yeah, we can call it symbol or symbol info. It isn't used after this call, so we just rename it to symbol info and use symbol info here as well. And it compiles now, and symbol info has the type info. It would mean that we can access the type field on it. Well, I think that we are done here, because everything else looks actually more or less fine. So what we have else? Procedure, declaration, get parameters, get temporaries. These are these two places, and we have a parser node, and it has type procedure declaration. That makes sense. And current parameter this is also a loop through a list, so we read the parameters from this node. List iteration is implemented with labels and gotos. We don't have loops yet. Actually, the loops are nice to have, but I think that the language is missing more important features than loops at this stage, so I can handle a few go-tos till we have loops. And the second case was this one, and we just assigned to this current parameter now temporaries from this loop, but this current parameter isn't actually used anymore, so the parameters or temporaries just pass to this procedure, and therefore we can just use it as is. Temporaries, and so okay, looks better. Declaration get label parser node label declaration. So parser node is a label declaration, and we get the label name, and we get the label name length from the node. We don't need all these variables anymore. So we do not support calling procedures in the parameters of a procedure. Therefore, all of these temporary variables were needed, but we don't need them anymore. And if the procedure only has a return statement, then begin isn't needed anymore. Why we have only this TSC function call? What does it? Elna TSC label. It is used. It is defined here. Okay, it is used in the few more places. Okay, let us look for the declaration get. These are the three last usages of declaration getters, and the parser node is a procedure declaration. We already know it. So where the name pointer is used, name pointer is used at the end, and parser node is probably isn't reassigned or something like this. No. So instead of name pointer, we can just say parser node name and parser node length. Seems all right. And here's declaration get next. We need to set the type of the current parameter, and it's parser node parameters, and it is a declaration. It's probably a or parameter declaration. So current parameter, we say that it is a pointer to a declaration. It should be enough, and we can just say current parameter next, and this should probably work. And I should not forget to remove two unused variables. So now we look for these conditional statements. Get, there aren't anymore. If statement get, if statement get, nothing. Return statement get, okay, it is used here. And parser node is a return statement pointer. And now we can just say parser node dereferenced returned. The return field contains the return expression or the returned expression, and we can just pass it directly to the procedure, and then we can remove this thing. And also remove this variable. I probably already checked the assign statements. Or just statement get. Okay, there are go-to statements as well. Let us begin here. So we have parser node. This procedure converts a go-to statement into the intermediate representation. So the type of the passed node is go-to statement pointer, and that means that label name is used once, and we can just say parser node label and remove this thing here. And then label length. Label length is used in the next statement and here as well, but it doesn't change. Let us combine this plus thing. So where the label length is used directly, we just pass the expression with the field access, so parser node length. And what we do, we assign to this variable parser node length plus 1, and we pass this. It will break, so we need to remove plus 1 where the label length is used, so we do not do this addition multiple times. Okay, And we had another statement get, the last statement getter, and we have a parser node here, and parser node is reassigned with the next statement from the list. So basically parser node is any statement pointer. Then we can check whether it is nil or not, and this is fine, but here we get the next element in the statement list. Then we have type info get, not anymore. Not re-expression get. I probably know there is still one usage, get type decoration from this parser node, and I think that we need an additional variable to solve this. So parser node is a dereference expression, and we get the reference expression and we get the pointer. So I suppose it's basically the base type of the reference, not the base type, the base expression. So pointer is the expression that is dereferenced. And we can just call it this. So we say that we have a new variable, the referenced expression, and we say its type is L0 expression because it can be basically any expression. And we assign this parser node pointer to this variable. The referenced expression is parser node pointer semicolon, and then we can access the type decoration on this reference expression. So the referenced expression type decoration, and that is it. We see here another getter usage. So base type has the type Elna type pointer, and we can now get the kind of this type. And we can use this directly. If check for compatibility should be removed later, can we remove it already? No. Okay, then not. base type kind pointer, then so it says that if the type is a pointer, then we get the base type of that pointer. Otherwise, we assign the type itself. I'm not sure why it doesn't work. But well, I suppose we return later to this if condition. It is not our mission now. We can also rewrite it as if-else statement. I think no, we cannot. Get base. So we have here this get base. This means that base type is ELNA type pointer, which isn't true. Base type is ELNA type. Let us add a variable pointer type and give it the type ELNA type pointer. So if the type kind or the base type is a pointer, then we need to cast this base type to a pointer type, and then we can get the base type of this pointer type. So we can say pointer type base. Well, it is fine now. So type in forget. Now our usages. ELNA3 expression get. Now other usages. ELNA3 expression get. ELNA type get. ELNA type get. Now other usages, ELNA type pointer get. ELNA type pointer get. Okay. I do not find any further usages. Let us go to the function, to the procedure that generates these getters, because we can then check if we still get some getters used. So this is basically this function, and it won't generate anything else. So if we don't generate getters, then this procedure will return nil, and that would mean that last result is just will be last result. Is it always assigned to something? Yes, it is assigned to something. So Okay, we still have a few getters. This is elna3 variable expression get. You can see it in this error message here, so it is reported by the linker because it cannot find the symbol since it is not defined anymore. We remove the comment again and variable expression get. Okay, these are these two usages. So this parsed expression is what? Parsed expression is elna3 variable expression. It is a pointer. It is the name of the procedure, the expression that describes procedure name. So then we can just say name and length. Where is this name used? Here once. And name length as well. Is this parsed expression reassigned anywhere? Yes. So we just leave it as is. And we go back to the elna_tac type field and try this once again. So it was this call and we put a comment around it. And now it seems to compile. So elna_tac type record. We define here this size. This is the procedure that gives us the size of the record. It will be still auto-generated. Then we go through all the fields and basically generate the procedures for the fields. But I think that we do not need this loop at all. Let us see. So tac type record fields. This label is only used in this if statement because it is basically a loop. We can just remove the whole block, I think. Exactly, we can get rid of the whole thing here. So we return the first result. Current result is last result. Last result is first result. Yeah. So basically we can just assign first result to the current result because we do not have a lot of we had 3 auto-generated functions before, but now we have only 1. So there is no need for this list with first, last elements and so forth. So we can just assign this first result to the current result and remove this statement, and first result is basically already this size function, so it's the only generated declaration, and I suppose that this last result is probably isn't used anymore. A result isn't used either. So let us do the following. We remove the first result and we rename the first result to just result, so this nil can go. I can even use current result directly, but we leave it as is. So let us try to compile it once again, and it doesn't work. Current result. Result body. Current result is result, and we return the first result. Okay, let us go now to this LNTIC type field procedure, because it isn't used anymore. And let us see what it uses. It uses it uses as well this LNTIC accessor procedure. It can be that it isn't required anymore. We have set operand, this, everything else is used. So we get rid of this procedure. And we have also this LNTIC accessor procedure that isn't used, so it can be removed as well. I do not think that it uses something that can be removed now, so we remove this procedure as well. And now we are done. We replaced all getters and setters with field access. We implemented in the stage 16, and we removed these generated functions. And I would say that I will finish here, and probably the next time we implement a few small improvements. I have to think about what to do next. So that was it